Now the other 5 columns in this data set are for a different study altogether. So we've got gender 2, okay, in this case 0 is male, 1 is female. We've got status, okay, this is an arbitrary social status measure, higher numbers equal kind of higher social class. Income 2, this is pounds per week of pocket money plus other income. Word score, this is a verbal intelligence measure. And gambling, this is how much people spend on gambling in a year on average within this sample. It's a slightly bigger sample than we had before. We've got 47 cases here. So what we want to do, first of all, is see whether gambling expenditure can be predicted from status, income, and verbal intelligence, that is the word score. So I'm just going to use these 3 to predict that one. So I'm just going to do this quickly. Regression, linear. So we can try to predict that using status, income, and verbal intelligence. Let's check this. Linearity diagnostics. Continue. OK. Now I'm not going to go through this in detail because the detailed explanation you will find in the tutorial for the other regression. So the output is same adjusted R-square, in this case is 0.406. It's a significant model, and let's look at what is going on here. We've got class, income, verbal intelligence, and the only one that's actually significant is income. As we can see, as income goes up, gambling expenditure goes up as well. As verbal intelligence goes up, gambling goes down. As status goes up, gambling goes up. But the only one that's actually making a significant contribution is income. Our collinearity statistics, the tolerances are nice and high again, so we don't have a problem. Okay, so now I'm going to add in gender to see if that makes any difference. So I'll throw in gender 2 into the independence, click OK. As you can see, our adjusted R-square is now 0.482. And what's going on now is that income is now significant as it was before, and gender is also making a significant contribution. Tolerances are okay. So if we just go back up to what we had before, our adjusted R-square was 0.406, that is 40.6% of the variance in gambling could be predicted using verbal intelligence, income and class, but the only significant predictor was income. But now if we add in gender, we see that's gone up to 0.482. Okay, so it's gone up by 8%. So by adding in gender to the model, we've accounted for another 8% of the variance. So this just shows you how you can add in variables, or take variables out to see what individual effects they have to the overall model, to the amount of variance that's explained. Okay. So in this case we know that adding in gender seems to explain an additional 8% of the variation in gambling as measured in pounds per year. And that's basically